The distance formula is kind of a big thing. It's gone. I put it up there for another class earlier. Distance between 2 points on the coordinate plane is the square root of what?
x1 and x2 squared.
What about x1 and x2?
They're in, oh,
Add
minus
'em?
and plus.
Subtract them. And then
Square.
square the difference. Okay? Because that's the distance between the 2 points.
And then add.
And then add. Okay, so that works, right? Okay, so then if you're given 2 points, which are x comma 3 and 2x comma 5, and that's equal to 3. That distance is equal to 3. I better write this all down. So if the distance is 3, and the points are these, we gotta figure out what x is, huh? Write an equation that you would solve in order to find the possible values of x. So you gotta write the equation, you gotta find the values, and then we gotta use the distance formula to check that the points that we found work. So we gotta just do it, check our work. So in this case here, that's your x value, that's y. That's the other x value, and that's the other y. So you just plug it in and start trusting your math. So the difference between these two,
It says without using the square root.
write an equation you would solve in order to find the possible values of x. Hint, you can write this equation without using a square root. Okay, so if I don't have a square root here, what do I have to do to this? Okay. All right, so this is going to be squared. That'll make it easier. And now the difference between these. So what's this? 2x minus x squared. That's 9. That's what number squared? 2 squared. So we'll just simplify. So then, how do I find what x is equal to?
Square root.
This is the tricky part. So then what's x equal to? It's equal to the square root of 5? Is that where we want to stop? What we get for an answer out here could be put in for x and get squared. What happens when you square a positive number? It's positive. What happens when you square a negative number? It's still positive. So, get rid of this and look back at it. We're looking for a number that gets squared that equals 5. How many solutions are there? There's 2. It's both the positive square root and a negative. So that has to be plus and minus. And the kind of the rule that we follow is whenever we're taking the square root of a variable, in this case, there's 2 answers. There's the positive and the negative. It's just like what I showed you the other day with what we come up with in a parabola when you're using the quadratic. There comes a point where you take the positive and the negative of the square root of b squared minus 4ac. Same thing happens here. We have a variable under the square root, so that we have to have the square root of 5 and a negative number, square root of 5. So it's a little bit bigger than 2. negative 2 point something, this is positive 2 point something. So that's why they say the possible values in this question. So those are the two possible locations for x that would work so that this distance between the 2 points is 3. And can you picture that?
Yeah.
Can you? You can picture it? Could you draw a picture of what that would look like?
Negative, what's the square root of 5 on the negative square root?
Yeah, well, where they would look like on a grid.
Yeah.
So this is something at 3, right? So they would be up 1, 2, 3. So somewhere along here, x distance is a point. So let's just say that right here is the distance of x. So this location right here would be x comma 3. And this location would be twice as far. So we gotta go 2 times x, and we gotta go up 5. So that's up here. And that distance is supposed to be 3, right? Does it look like it's 3? From here to here? Could it be? Possibly. Okay, well, what if you did this? What if you went now in a negative direction? So you did a negative x direction. That's going to be over here, isn't it? Or over here. And then, so if you went negative x and up 3, you'd be there. If you went negative 2x and up 5, you'd be there. So you'd still have a distance that would be the same. It would just be located somewhere else. So the relationship between these two numbers is that one is just twice as far away as the other. And then these points are on an angle to one another. Or they could be the opposite direction and then on an angle to one another. But we don't know where they are. They could be two things. See, this distance here could be the square root of 5, while over here it's a negative 2 point whatever. And this would be twice the square root of 5. Or over this direction it could be a negative 2 multiplied by the square root of 5. Negative direction. So if you use the distance formula to check that the points that you found are indeed 3 units apart, you just want to take this number here, square root of 5, plug it back in, do all the arithmetic here and see if you get 9 without the square root symbol, and then put a negative root 5 in here and do the same thing and see if you get a 9 without the square root symbol. That's how you would check that answer. Okay, so means and midpoints. The last thing I said to you with this on Friday was, I'd like you to come up with an algebraic relationship that describes how you find the midpoint of a horizontal line, how you find the midpoint of a vertical line, and then how you find the midpoint of a diagonal line on the coordinate plane. Some of you were at a point where you were constructing the midpoint to see where it was. Others of you were further along with that. So, if you need to get a dry compass yet, go grab one, okay? Jeez. Hey, Titus, can Sorry.
Gonna wear that all week?
Sally?
That has one outfit for the whole entire year. That's probably, that's what I
Everybody left their name on.
I wear it, but I would. Anyway, just had 1,000.
Looks like you.
1,000 characters.
That is yours.
This isn't Mango.
That's not yours. That's Sally's, that's yours.
Is this yours? Everything?
Here's Haines. That's all yours? Like that? Somebody really went to town on this one. This is Allison, is this you? This says you. So who am I missing, Seth? Is this you, Seth, all of that? Who's there?
That's mine.
That's yours? Okay, here's Luke's.
What?
And this is Art. This is what I have, Art. You have the graph part of this though? Where's the stuff, huh? That's all we have. Does anybody have other work stuck to theirs?
Is that everything?
That's it. Dun, dun, dun.
Is this yours, Galen?
I'll say card. That's not mine.
Oh. That does say orange. Alright, here's yours. Sweet.
You not read my writing?
No, I couldn't. It was Mary who read that.
That was in the book.
Thought it might have been Galen.
Like, look how close
Right
the,
to the graph.
look the other side.
Mile?
I mean, actually,
Yeah.
you just have.
Because moving slowly, and it's like, you know, right relationship. You know, like, I don't know where my work is. Probably take the. Maybe you can take some of those. Using, finding the midpoint through, I mean, you know what we did.
Yeah.
So how much of it? I'm just doing it, okay?
Yeah, just do it.
Yeah, let me
You know where
just-
you left off.
Yeah, well, it's not where I left off, because these guys have, I want these guys on their own to find the formula for making. That, okay. Sorry, I'm discombobulated. I'm just gonna put Max's on here really fast. And then. What I want. What? I'm looking really fast at what I did on Friday.
Oh, there's,
So I know I did these, but then those points there. Come on, get it going. Okay. You can take a picture of that. Okay. Okay, so here's what we need to do. We need to draw a segment between these 2 points here. This is X. And these 2 points. Like that. And then connect them. With a segment. And then locate the middle of that segment. And then label what it is. Then go to those 2 points. I'm gonna write those for you. I'd rather write them.
Way.
So I have -2, -6, and then -6. Connect those. Go to 2. And so 8. And then you have a -5, 2. And a 7, 10. So create a segment, and this is going to be diagonal. So just plot the points. And then you just draw a compass. I'll show you how we can do it once we do it. So this is drawing just find the midpoint of all the segments. So you only got that far, didn't you?
Yeah.
So in part, let me get you like this big graph here, and we do it so on the floor. So now can you set those ordered curves in between each of these so you can both look at them? Here's your coordinate plane. Plot the points. And then using what we did with the drawing compass to find the midpoint of the segments. Use the drawing compass to find the midpoint of the these 2 points on the segment. These 2 points on the segment. Those 2 points on the separate segment.
I remember.
Yeah, so we started doing it, but I don't know that, I think you saw us doing it, but I don't know that you actually got going on that one. So you're using your resources. Good.
Yeah.
So does that work?
I used this one first.
This one works for those 2 points? How about that? Does that work for the horizontal line? Work for the vertical line if you change it to y.
Oh, if you change it to Y, so yeah, I think it
Okay, good. This is the critical one, because this encompasses both of those.
yeah, that'll do it.
Okay.
Probably so.
We have 14, 16, 18. So you're ready for that? Mm-hmm. Just a second. I see your work? Can I put you on stage?
Yeah, sure.
Okay. Okay, so. Gosh, is that going to fill the screen? I know, this is ridiculous. Okay, so what Jacob did here is he took a vertical line from the points negative 4, 2 to negative 4, 8. And then he constructed the midpoint using a drawing compass, which was negative 4, 5. Did the same thing with a horizontal line from negative 2, negative 6 to 10, negative 6. Found the midpoint with a construction 4, negative 6. Then he took a diagonal line between these 2 points, constructed the midpoint, found it to be 1, 6. Then what he did is he went to the theorems for a horizontal line, but you just change it to the y values for a vertical line, and finding the midpoint on a plane. So we did a lot of work on Friday with this. We also did midpoints of these figures, a kite and a rhombus. And we connected the midpoints, and we found with a rhombus that you connect and you come up with a rectangle. Then you find the midpoints of the rectangle, you go back to the rhombus, and back and forth and back and forth. The kite, the midpoints turn it into a rectangle when connected, and then it turns to a rhombus, to a rectangle, to a rhombus, etc. So that was just an exercise on Friday to work with construction of midpoints. So with that, use this theorem here, and you should be able to do your homework. That was for Mac.